Okay, so this is the beginning of your exam review packet. For number 1, to make the sketch of the piecewise function, I'm going to think about the two different pieces, x plus 1 and 3 minus 4x. So for x plus 1, if I want to get some xy values, I'm purposely going to choose values less than 0 because that's the break in the piece. So it's 0, -1, -2. And when I plug them in here for x, we get 1, 0, and -1. Can do the same thing for the 3 minus 4x piece. And we're going to pick values for x greater than 0, but I'm also going to include 0 because I need to put an open circle there when I draw that piece of the graph. Let's do 0, 1, and 2. When I plug in 0, I get 3. When I plug in 1, and when I plug in 2, and now I can plot those points, 0, 1, -1, 0, -2, -1, and it's array going in this direction. And now for the other piece, 0, 3, but at 0, 3 I'm going to put an open circle. Kind of missed the point there. And then 1, -1, and 2, -5. And then it's array. Try to connect the dots as best as possible. Oops. And it's array in this direction. There, it's better. Now we're going to go backwards for 2 and 3. We have to write the equations. So when we write a piecewise, we need a function name. And then our pieces we're going to get by doing mx plus b. So our y-intercept for this left piece is at 3. And then if we count our slope up 1 and over 1, that's -1 for the slope. And that's every x less than 0. And I did less than because your y-intercept has an open circle, so it's not equal there. Now for the other piece, we have a y-intercept of 1. And if we count the slope, it's up 1 and to the right 1, so that's +1 slope. And that's for every x greater than or equal to 0. Okay, so for number 3, the piece on the left, you can see it has a y-intercept here of 2. I'll call this one g of x. And the slope, if I count it, is up 1 and to the right 1, so that's +x. And that's for every x less than, and this point happens here at an x value of 1. So it's for every x less than 1. And now these pieces as a step, they're the greatest integer function. So I'm going to write it as the greatest integer function, and that's for every x greater than or equal to 1. Now for number 4, we have to write our equation for A. So the cost, if it's a shipping charge for every order, it's $12. So it's automatically going to be plus 12. $5 per item, so that's 5x. And that's for 5 items or less. So x is less than or equal to 5. If it has 5 items, more than 5 but less than 10, it's $4.50. So that's 4.5 times x. And that's more than 5 but less than 10. And then if we have more than 10, 10 or more. Here's our flat fee, and then it's $3.50. Oops. So now for part B, we want to see what would cost $48. So, I don't know, $48, that's a lot of money. So I'm going to start with this piece of the equation and see if I can get an integer answer for x, because we can't have a fraction of a package. You can only have a whole number, an integer. I'm sorry, I should say a whole number, not an integer, because we can't be negative. So then this is 36. And 36 is not going to divide evenly by 3.5, so that's not going to work. So let's try the middle piece. Subtract the 12 again, so 36 equals 4.5x. And now this problem you could use a calculator for, so when you divide by 4.5, we're going to get 8 as our answer. So that's 8 items that they can be gift wrapped and shipped. Okay, so now for number 5, to sketch a graph. Let's see. Our vertex is at -2, -4, because in the absolute value equation here, we have x minus h, so minus -2 would be that plus. So -2, -4 is my vertex. And then the 3 in the front stretches it, and it's going to open up because that 3 is positive. So I'm going to go up 3. 1, 2, 3, and over 1. But it's symmetrical, so I also have to go to the left one, and when I connect my points, we get our absolute value graph. So now I can use this graph to help me answer the rest of these questions. The domain is all real numbers, because there's no x that you can't plug in. So I'm going to say x is all reals. The range, the lowest y value here is -4. So that's y is greater than or equal to -4. The axis of symmetry goes through the vertex this way. And that's a vertical line, so that's x equals -2. And the minimum value is the lowest y value, it's -4. So the transformations, it went to the left 2, down 4, and stretch by 3. So is the function continuous? Really what that's asking is, can I draw the entire equation without lifting up my pencil? So if I trace it, I didn't have to lift up my pen at any point, so yes, it's continuous. An example of a non-continuous function would be any of the piecewise in the first 3 problems of the packet. Okay, so now for number 6, f of g of 3. So first we have to find g of 3. So when I plug in 3 to g, we get 6 minus 8, that's -2. So now I need f of -2. So that's -2 minus 3, so our answer is -5. For 7, f of -7 is -10 when you plug in x here. And then plugging that into h, so h of -10 is -10 squared minus 2. That's 100 minus 2, so we get 98. Okay, so for problem number 8, we're going to add the f and g functions together. So I'm going to combine like terms. So that's going to give me x plus 2x, which is 3x, and then the constants, negative 3 and 8, is negative 11. So really I can write that as 3x minus 11. Okay, so now for number 9, I'm going to be more careful because it's subtraction. So that's going to be x minus 3 minus the quantity of the g of x function. And the reason we have to be careful with subtraction is because that negative gets distributed to both pieces. So now that's negative x, and now we get positive 8 minus 3, which is 5. Okay, so for 10, we're going to multiply. It's x minus 3 times 2x minus 8. You can box method, you can FOIL, you can distribute. We're going to get 2x squared, and then negative 8x, negative 6x, and 24. So combining like terms, that's negative 14x plus 24. Okay, for 11, when we divide, f is the numerator and g is the denominator. And nothing can simplify. These x's can't cancel because of the subtraction, because you have binomials. But to answer 11b, the domain, when you have a fraction, the denominator can't equal 0. So if we solve that, that means x cannot equal 4. So the domain is all real numbers, but x cannot equal 4. Now for 12, g of h, so I'm going to replace the x in the g function with x squared minus 2. And we have to simplify, so I'm going to distribute the 2. And then combine like terms, so we get 2x squared minus 12. And then lastly, for 13, h of f, so anywhere there is an x, I'm going to replace it with x minus 3, and now you have to be really careful. X minus 3 squared means x minus 3 times x minus 3. And we have to multiply those together. FOIL, box method, distribute, and then combine our like terms, so we get x squared minus 6x plus 7. Okay, so, and then for number 14, the domain of f of g. Well, first we have to find f of g. So for f of g of x, that's going to be the square root of 16 minus 2x squared. So that's the square root of 16 minus 4x squared. So I needed that to be able to know what the domain is. I have to set the radicand, which is underneath the radical, greater than or equal to 0. So now we have a quadratic inequality to solve. I'm going to make my sketch a little graph. If I solve this, I get x-intercepts. Let's see. If I pretend it's equal to 0, add the 4x squared over, divide by 4, so we get plus or minus 2. And then the parabola is going to open down since that's negative. And I want everything greater than 0. That's up here. So the domain is any x between 2 and negative 2. So now we're going to do similar for b. We need g of f. That's 2 square root 16 minus x squared So we need to know when 16 minus x squared is greater than or equal to 0. So if I find the x-intercepts, we get plus or minus 4, because we square root both sides. And this parabola still opens down because of the negative x squared. And we want greater than or equal to 0, which is above. So that domain is any x between -4 and 4.